Share. Okay. All right. So I'm just going to kind of start from the beginning with the 4 equations, and then we'll do a few practice problems to review. So the first equation that we learned about was molarity, right? What is the equation for molarity? Moles over liters. So you have to have that memorized. We won't give that to you. So molarity is in terms of moles divided by liters, and it tells you the concentration of something. Molality is really similar. It's a lowercase m, and then what's the formula for molality? Close-ish, not grams per liter. Anybody else? Okay, kilograms on bottom, right? And yes, moles on top. So the only thing that changed was the bottom, right? Liters to kilograms. So molarity and molality are both units of concentration. With molality on the bottom, it's the solvent, and on the top, it's the solute. And also with molarity, the top is the solute, and the bottom is the entire solution. Okay, but the main thing is that the solute always goes on top. Okay, and the solute, we'll go into that in just a second. The next equation we learned about was dilutions, right? And that was from the formula M1 V1 equals M2 V2, or in other words, MC VC is equal to MD VD, where C means concentrated and D means diluted. You can use either of these equations to get your answer. So that's dilution, and the last one was percent solution. So what's the equation for percent solution? I don't know. What'd you say, Ivan? Yeah, okay, basically, it comes down to part divided by whole times 100. And so often what that looks like, it could be like the solute divided by the solution, right, times 100%, because that's like the part divided by the whole. So just to summarize, a solution is made up of 2 things. What, can y'all remember what the 2 things are? Yes, solute and solvent. And so when a problem says solution, it means solute and solvent, right? And there are 2 parts to a solution, these 2 things. The solute is what is being dissolved, and the solvent is the agent that does the dissolving. Being dissolved does the dissolving. And so often the solvent is water, but it can be anything. Another common solvent is alcohol, does the dissolving. But water is considered the universal solvent because it's polar and it breaks things down and can help dissolve things really easily. So we have 4 equations, and basically on all of these questions, you just decide which equation to use, make sure your units work out right, and then solve the problem. So let's read this first problem that I passed out. What equation do y'all think we should use for the first problem here? Yeah, exactly, because it's asking for molarity, right? So what is the molarity? So we know that we're going to use this equation, moles per liter, right? The next thing we need to do is identify what goes where. And so it says that there is 250 mils of solution. So that number will go down here eventually, once we get the units right. And then here's our solute right here. The calcium sulfate is the solute. So ultimately, we're going to use that number, and that's going to go on top, but we have to have the units in the correct units first. So let's do the solution first. So 250 mils, what's wrong with this right now? It's not in liters, so we need to divide by 1,000 to get it to liters, right? The long way of doing that would be just, so for every 1 liter, there's 1,000 milliliters, right? So milliliters cancels out. So that would be 0.250 liters for the bottom part. And now we got to deal with the top part. What do you notice about the units of our solute there? It's in grams. We need to get that to moles. How would we get from grams to moles of something? Yes, so to get from grams to moles, you always divide by the molar mass. So to do that, we need to get the the molar mass, so we need to find out the formula for calcium sulfate. And so to find the formula, you always, since it's we're going to write down the symbols and then cross over if it's an ionic compound. So what's the symbol for calcium? Ca, and since calcium is a metal, it's going to be ionic because ionic bonds always have a metal. And so what charge does calcium have? +2. So this says sulfate. Remember, so sulfide would be sulfur, right? If it ends in "ide," it's from the non-metal side. But because it ends in "ate," it's always going to be on the polyatomic ion sheet. If it ends in "ate" or "ite," right? So what's the formula for sulfate? SO4, great job, with a -2 charge. And so because these charges are the same, they're going to cancel out. So you don't have to do any crossing over here. Our formula is going to be CaSO4, right? That's because the charges canceled out. It's not always the case. So then we just need to add up and get our molar mass for Ca, S, and O, right? According to our normal thing. So y'all grab your periodic tables. Let's do this one together. So what's calcium's molar mass? 40.08, way to go. What about sulfur? Okay, and then oxygen. Okay, and then we need to multiply each of these times how many there are. And there are 4 oxygens, right? So 16 times 4 is 64. I only know that because I've done this for 3 times. I got it wrong the first time. I said 96, so just know that. And they were like, no, but they didn't do the adding. They made me do it and get it wrong. So now we're going to add this up and get a mass here. So what do y'all get whenever you add that up? Thank you so much for adding that up before I asked. There's so many periods where I'm just staring, and finally I'm like, all right, let me get my phone out. 0.15, I'm sorry. Okay, I still got it wrong. Okay, 136.15, I'm sorry. So this is the molar mass of calcium sulfate. So we're going to divide by that because we need our 46 grams to be in terms of moles. And we know that 136 grams is 1 mole. So we can divide by that number. So what do y'all get when you divide? Move this over. 0.338, perfect. And that would be moles of CaSO4. Okay, so now that we have our moles of CaSO4 and our liters of our solvent, we can divide the two. So I'm sorry, liters of solution, not solvent. So molarity is moles per liter, right? So that would be equal to 0.338 moles for every 0.250 liters, right? So when you divide that, you'll get your answer. So what do y'all get? 1.35, and then you can say moles per liter, or you could say 1.35 capital M, right? Because molarity is moles per liter. So you can show your units either way. And then we need to round, and how many significant digits does 250 have? So trailing zeros only count when a decimal is present. So there's actually only 2 there. If it said 250 period, then there would be 3. But when there's no decimal present, it's just 2. And then this one's got 3 because the decimal's present. So we're going to round to 2. That's our lowest one. So we're going to make that 1.4 M for our final answer there. Okay, so we just converted grams to moles and then divided moles by the liter amount once we converted milliliters to liters. Any questions on that one? Okay, let's read the next one and see what equation we think we should use. Calculate the mass of solute needed to make 3,200 mils of a 3.5 capital M sodium hydroxide solution. So what equation should we use? What's that? I'm sorry, I thought you said something. What equation do y'all think we should use? Yeah, okay, M1V1. So I see capital M, so it could be M1V1. I see a liter amount or milliliter amount. And it says calculate the mass of solute. So again, this is going to be a molarity problem. M equals moles per liter, right? Because they didn't give us a second volume or a second molarity. And so it's not going to be a dilution problem because they would have given you a second one. So our M was given to us. Our M is 3.5, right? And they also gave us the volume amount. So we need to divide that by 1,000, 3,200 times 1 over 1,000. That would be 3.2. So that was what goes on bottom, 3.2 liters. And moles they did not give us. So that's our X, right? So it says calculate the mass of solute needed. So we're going to find X first. And so when you solve for X, what are y'all going to get here? 1.09? So we should multiply both sides times 3.2, right? Well, because trying to get X by itself. It's all right. It's all right. 11.2. And what is our unit going to be? So let me be thorough here and let's write this really neatly in a way to where you can see how every unit cancels out. So I'm going to write 3.5 moles per liter because capital M means moles per liter is equal to X over 3.2 liters, right? So I just changed the capital M to moles per liter. So when we multiply both sides times 3.2 liters, right? The liters will cancel out and this will completely cancel out, right? So what unit will we be left with? Moles, right? So we have moles of our substance and it asks us to calculate the mass, which would be grams, right? So what do we need to do next? Moles to grams. We got to get the molar mass of that thing. So we got to get this and get it into a formula so that we can calculate the molar mass. So sodium is what? What symbol? Na with the +1 charge, and then hydroxide. Yeah, so hydroxide, you should have memorized at this point. It's one of those polyatomic ions. Hydroxide is OH. And because it's, again, 1 and -1, it's going to cancel out and be NaOH. So we're going to add this up, right? So 22.99, 16, and 1.01. When you add all that up, you should get 40 exactly, right? Which is really satisfying. So are we going to divide or multiply? What are we going to do with that 40? Yes, because we're trying to get over 2 grams for every 1 mole. So when you're converting to moles, you divide. When you're converting to grams, you multiply, right? Kind of just like those stoichiometry problems. So 11.2 times 40 is what? 446 grams of NaOH, and that's our final answer. So in summary, they gave us the concentration and the volume, and we solved for moles. We got moles, and then we multiplied by the molar mass. And that's all that we did. Okay, so what equation will we use for this one? Same one, right? So I'm going to let y'all try to solve that one later if you want for a couple minutes. Same type of problem there. Let's look at this problem here. What is the molality of 15 grams of ethanol dissolved in 250 grams of water? So what equation do you think we should use here? Molality, right? Which is moles per kilogram, which you'll have to know, right? So which one is, and it's moles of solute per kilogram of solvent. So which one is our solvent here between the two chemicals? The solvent is the thing that is doing the dissolving. Yes, so water is our solvent. So I'm going to write that above it, solvent, which means that ethanol is our solute. Water is like, if water is there, it's probably going to be the solvent. And you also, the way it reads, it says the ethanol is dissolved in the water. And so, you know that the water is the solvent. So now we can convert to the correct units. And so for the water, what do we need to do? We got 250 grams of water. What do we need to do with that? Yes, we got to convert to kilograms. And so again, for every 1 kilogram, there's 1,000 grams. So we're going to divide by 1,000 or move the decimal place over 3 times. So 0.250 kilograms. So that will go on bottom. And then what do we need to do with the 15 grams of ethanol? Yes. So if you notice, we start with grams of both. but one goes to kilograms and one goes to moles. So they kind of go in different directions. So we need to get the molar mass of ethanol. So we need to just add up C, H, and O. So 12.01 times 2, 1.01. How many H's do we have total? 6 H's total, because 5 plus this one, right? And then we've got 1 O. So in total, what would our mass be? 34? I think so. Okay, 46 sounds, you're fine. That was good. Yeah, it's okay. I think it's 46.08, okay? So we're gonna divide by 46.08. So that's gonna get us what when you do that? Okay, 0.325. So that's 0.325 moles of our solute. So that's what's gonna go on top, right? So M is gonna be equal to 0.325 divided by 0.250. And it'll, yeah, so what is that y'all get? 1.3, perfect. And that's the correct number of significant digits, because 250, again, has only 2 digits in it that are significant. Okay, so let's read this problem here. If 55 mil of 3.5 molar acetic acid is added to 43 mils of water, what is the concentration of the dilute solution? So what equation should we use here? Yeah, M1V1, because I see volume, concentration, and then a second volume. And it's asking for the second concentration. So our M1 is 3.5. What's our V1? That's good. That would be our V2. You were close. Our V1 is going to be 55 because it says 55 of 3.5. So these two are together. This is our V1 and our M1, right? And so let's talk about M2. What's our M2? X. Great job. Yeah, that was kind of a trick question. It didn't give it to us, right? And so our V2, you'd think it would be 43, right? But I kind of wrote this above for my previous class, like just to talk about it. If it says it's diluted with, then you add them together, or like it's added to, because it says it's added to 43 mils. So it's not going to be 43 total. It's going to be 43 plus 55, right? But if instead it says for a final solution or the overall solution, or just the solution is blank, then you don't add it. And so you have to look at how they're wording it to answer that part, okay? Okay, you're fine. Okay, so then we're going to plug it in. So 3.5 times 55 M1V1 is equal to X times 98. And you'll just solve for X by dividing both sides by 98. So what's your X? So M2 is equal to, what'd you say, 4? A 1.96 capital M. And because we've got 2 significant digits here, we're going to make that 2.0 molar. Okay. Any questions on that one? Okay. Let's look at this next one. Are they all number 1? Which one? Oh, I think the formatting got messed up because every time you press enter, it like reformats it. I know they all want to be number 1 and they're not. But okay. So I don't even know what number this one actually is, but it says number 1. Number 6. Okay, so we're gonna write that right here. How many grams of sodium chloride are needed to make a 1.25 molal or little m solution containing 250 grams of water? So what equation should we use here? Yeah, I see a lowercase m, so it'll be moles per kilogram again, right? And we're solving for grams of sodium chloride. And sodium chloride is the solute. So we're going to be solving for the top part because the top part is where the solute comes from, right? So our m is 1.25, right? And then we can kind of break it down to be really neat. Our m is 1.25, and then our solvent is 250 grams, right, of water divided by 1,000. So it's going to be 0.250 kilograms. right? So now we're going to plug those in. So we're going to say 1.25 is equal to X over 0.250 kilograms. And if you want to make sure that your units cancel out, you would write 1.25 moles per kilogram, right? And now how do we solve for X? Yeah, we're going to multiply both sides by 0.25 kilograms, which would make kilograms cancel out here. We're going to cancel that out and cancel that out. And so what will our final answer be? Not our non-final, just our answer for X. 0.31, is that 3? Okay, sorry, I kept talking over you. Okay, 0.313 moles, and it asked for how many grams. So we're gonna take that mole and multiply by whatever molar mass NaCl is, because sodium chloride is NaCl. So you would add up their molar masses, right? 22.99 and 35.45. That's not a fun one to add up. I think it's 58.44. So 58.44 grams for every 1 mole. So when you multiply that, you'll get the mass, which is your final answer. So what do y'all get when you do that? 18.1 grams of NaCl is your final answer for that. And we need to reduce that to 18 because there are 2 significant digits in the 250. Again, from this 250 right here. Okay, let's look at this next one, which is apparently number 7. So what type of problem is this? Okay, percent solution. So that is part divided by whole times 100%. So what is our part here? 63. And our whole is actually not just going to be 87, right? It's going to be 87 plus 63 because it says 63 mils is put into. So if it said for a total volume or the entire solution or the solution, that's fine, but it doesn't say that. So we need to add those two together first. Would that be 150? 140? 87 plus 63. 150, okay. So we're gonna do 63 over 150 times 100%. So what do y'all get when you do that? 42%, and we keep 2 digits, that's perfect. All right, let's do this one and then we'll call it good. Okay, what type of problem do y'all think this one is? Percent, okay, perfect. So we're gonna do that again. So it'll be 32 divided by 461 plus 32, because again, it says the 32 is dissolved into it. So it's gonna go into the 461 times 100%. So what do y'all get? 6.4%. All right, so why don't y'all practice a little bit longer with the rest of the problems?